Oh gosh, Steve Spangler's here with the show stealers, the kids, the super smart
They're
kids.
always the smart ones, right?
Yes.
It's the one when we need help. That's exactly what we have to do. Two friends today, Kim. We have Ian and we have Zach. Ian, what school do you go to?
STEM.
STEM. Look right there and say hey to everybody.
Hello.
Yeah, and you didn't have to go to school today, right?
Right.
So this is kind of school.
Deal.
This is kind of school. Zach, where do you go to school?
Goddard.
Goddard. Look right there and say hey to everybody at Goddard.
Hi.
There you go. Kim, when the fire shoots across the table, just run.
Okay, I'm going.
We are doing something simple, but even though we're not catching anything on fire, it doesn't mean that we're not doing some really, really great science. So let's show everybody at home the setup and what it looks like, and then we'll explain the science. Fair enough?
Okay.
Okay, so we have three different trays here with milk. So will you put the milk in here? I just got the milk at the store today. So here's our milk. Good. And so we're using a lot just because it's the big show. You could use just a little plate of it. That would be fine. And Zach, will you take the food coloring and start with Kim filling that up with some food coloring. So just put some food coloring in there. Good job. That's perfect. Good, Ian. So we need some milk and food coloring. Ian, you can do the same thing. Kim, grab a couple of those and
just throw them in here?
Put it in here.
Okay.
Yeah, absolutely. So lots of it. So lots of food coloring all over the place.
Oh, boy.
Lots of food coloring.
So glad I wore white.
Anything that's worth doing is worth overdoing. So we need lots of food coloring. Good. I'll take some of that green from you here. So we want those milk molecules all covered. Good, got it. So this one was moving a little bit. This one was all by itself. So there was a little bit of movement just from you pouring it in. This here is buttermilk, and so that's not moving at all. 1% milk, 2% milk, and buttermilk. And now the very last thing that we're doing is I'm taking some soap. So you see the dish soap that's over here?
Right.
Putting the dish soap in here like this, and there's a cotton ball. So I think what we should do is let's get focused on one of the trays. Let's move over to the middle tray right here. That's perfect. Stay right there on that shot. Are you ready, Ian? You're going to pick up the cotton ball. Kim, you can do the same thing, cotton ball, and put it into the very middle. So the Dawn soap cotton
middle?
ball, ready, set, go. Drop it in. There it is. Look at this one. Look at it go. Nice job. Look at the movement that we have here. Look at this. It is moving around. Ian, you have to tell us what's going on, because if we did this with water, it wouldn't work, right?
Right.
So what's going on here?
So the dish soap is attracted to the fat in the milk,
Nice.
creating the colors to move.
The movement, how cool is that? So soap is really special because it has one end of the molecule likes the water and the other end of the molecule likes the fat, and it's kind of hooking onto it that way, and that's why you see this beautiful movement. Look at it churning over here.
That's really
Look
cool.
at the buttermilk here on this side.
Barely moving.
Zach, tell us why this is an experiment and not a demonstration, because people are thinking about science fair projects and you have to do an experiment, not a demonstration, right?
It's an experiment because there's a variable in